I'm Dr. Priya Rao. I'm Dr. Priya Rao, the founder director of Pelican Thermogenics Private Limited, a startup company based out of Cherthala in Kerala. And we are focused on manufacturing microwave heating systems, drying systems, primarily for waste management and secondary agriculture. I'm going to talk to you about a few thoughts and a few inputs on microwave drying systems for waste management and also in secondary agricultural applications. Thank you to Agriculture Information for giving this opportunity for me to share a few ideas and thoughts on these type of drying systems. We at Pelican Thermogenics are on a mission to provide modular based, microwave based dehydration or drying systems, enabling very efficient, rapid dehydration of the agricultural produce, food products, and biodegradable waste, thereby creating value additions by uniform heating and by retaining the nutritional value of the raw material and also providing a sterilized microbe free output in the process. I'll just brief you on the importance of microwave for dehydrated food and waste materials. Now, here I've just given you a gist about what is microwave heating and what are the principles that are applied in microwave heating systems. Microwave heating normally takes place due to the interaction of electromagnetic radiations with dielectric properties of foods, particularly with high dielectric materials like water, which get triggered during the microwave heating. And microwaves are part of electromagnetic spectrum in the frequency range falling between the IR radiation and the radio frequency range. The two frequencies have been set aside for exclusively use in microwave radiations, and they are 915 megahertz and 2450 megahertz. So you can just see the electromagnetic spectrum there. Now, we have a lot of conventional heating systems which are already in use, like hot air ovens, heating coil systems, which use steam jackets, coils. Heating oils they are all inefficient currently due to the conduction and convection losses that can happen. And in some cases, they also cause charring of the biological materials which come into contact with these type of heating systems. And also, we find that in these commercial, large scale applications, there are statutory requirements for boilers and similar accessories which inhibit small scale decentralized processing centers. So, when we talk about the microwave systems for dehydration, for drying, for removal of moisture in food materials and in waste biodegradable materials, there's a huge opportunity because we can create a lot of value added products like dehydrated vegetables, dehydrated seafood, dehydrated foods, dehydrated fish, prawns, and also converting biodegradable waste into dehydrated products which are in a lot of value additions can happen. Now microwave heating, I'll just brief you about microwave heating here. Now we all know microwave heating is a very efficient form of heating. You know, we all have microwave heating systems in our homes, and what we see is that you just take a small vessel, you put it into the microwave oven in a few seconds, in a matter of seconds, in a matter of minutes, the heating is completed, right? It heats up the matrix and not the containers per se. So it starts. So what we say in microwave heating is the heating is inside out and not outside in. So the container is not getting heated up here. It's only the matrix or the raw material inside the container that gets heated up very fast. And the heat loss due to the heat is considerably much low in the case of microwave heating. The nutrients of the matrix is not altered by the microwave. So retaining the retention of the nutrients is one major advantage of microwave heating and one of the most efficient and proven heating technologies in terms of reaction time and also in terms of energy consumptions. So, why has not microwave heating been very, very popular? Or why can't we have everywhere microwave heating systems present in the world? Well, there are a lot of challenges in the prior hour what is happening with respect to the microwave or radio frequency heating system. Although we know it is the most efficient form of heating, still we are not able to scale it up on a very commercial level to beyond 200-liter capacity or 1000-liter capacity, which can handle around 200 or 500 kgs of raw material at one point of time. So the main reason is because of the use of very high capacity magnetrons. Now magnetrons are the heating elements of a microwave system. So we use a zero point 0.9 kilowatt magnetrons, 1 kilowatt magnetrons, 1.5 kilowatt magnetrons, 2 kilowatt magnetrons, 3 kilowatt, 5 kilowatt, 10 kilowatts, and so on. Now, when I look into the cost of these magnetrons from 1 kilowatt to 2 kilowatt or 3 or 5 or 10, there is a huge exponential jump in the cost of these magnetrons, thereby making the system very, very expensive. So, if I want to incorporate a 10 kilowatt magnetron into my system to generate or manufacture a huge microwave heating or drying system, the cost of the magnetron itself will be running into lakhs of rupees. Now, multiple low capacity magnetrons in a single chamber can cause wave interferences between the two magnetrons. So, it is not possible to actually put in more low capacity magnetrons. Also, we have inflammable solvent based reactions face a threat of explosion because of arcing in the microwave reactors. Now, the advantages of microwave drying of agri produce and biodegradable waste, what we see is that there's a lesser connected load in the machine. There's a drudgery involved in the case of farmers or food processors or waste managers. There are a lot of regulations, as I told you earlier, because of using other accessories, and heat transfer loss and possibility of applications of solar power also is there in terms of microwave drying systems. There's a lot of reduction in the process time because what actually happens in the normal heating systems, in the microwave it is highly rapid and we bring down the time of heating. Therefore, what we can be doing in around 24 or 36 or 48 hours can actually be done very close to 2 hours, 3 hours, or even 4 hours. So it can actually double up your production. It can enhance your production capacity, and we only use low capacity magnetrons. For example, if I want to use a 6 kilowatt magnetron, for my system for a huge reactor vessel, I will be using more numbers of 1.5 kilowatt magnetrons so that I don't have to have a single 5 kilowatt or 10 kilowatt magnetron which can run into lakhs of rupees. Therefore, my capex is therefore reduced in the process. Low temperature dehydration under vacuum preserves the food nutrients of the raw material. The texture, the flavor is all retained in the matrix, and sterilization is additional bonus because we get a microbe free output in the process. The capital cost is in a conventional drying system considerably brought down by avoiding boilers, heat exchangers, water treatment requirements, steam coils, steam jackets, etc. So we just have a standalone system which has just a plug and play system. This also enables decentralized pasteurization, sterilization, reducing a huge amount of carbon footprint of transportation and packaging. That is a big advantage. So we are also promoting this in terms of United Nations sustainable goals because of using low carbon technologies, we're able to reduce the carbon footprint. If you come across a lot of fish processing centers, food processing centers, or restaurants, apartment complexes, vegetable markets, municipal markets, where they're handling hundreds or even sometimes 200 kgs of waste or materials in a single day. What happens is that when they have to, at the end of the day, when they need to store or stock these, they need to transport this into huge areas, into other areas for which they need to go to a centralized processing center. So here, with respect to the advantage of microwave heating systems are, we can create a decentralized unit, and wherever we create these type of materials or raw material requirements for drying and dehydration, we can set up the unit there itself. Therefore, we are reducing the carbon footprint of transportation and packaging. Okay, so now I'll just brief through with what type of problems we're dealing with now and why we came up with such solutions at Pelican Thermogenics. If you look at the global food loss every year, it's a whooping $680 billion. You can't even imagine the amount of the food loss that's happening in the world today. In India alone, it's around $200 million. And what we see, what we find now is that only 8% of this wasted food is actually converted into some kind of value added products. There are different types of dehydration techniques. We have dehydrated fruits, we have dehydrated vegetables, dehydrated seafood, and so many other products in the market. And also, we found that there are no commercially viable microwave systems in the market. So we started thinking about these problems and want to develop a solution. And at Thermogenics, we devised and have designed a solution which we have named it as MAMA, the Multiple Magneton Heating System. What is MAMA? MAMA is a decentralized, modular, low capacity, multiple magneton, microwave based rapid dehydration system for small scale fruits, vegetables, fish farmers, farmer producers organizations, FPCs, and all biodegradable waste managers, including municipal markets and apartment complexes. Wherever we have bulk generators of food waste, we can use MAMA. Who need rapid dehydration of the produce and the food and also value addition of the byproducts. Mama is a microwave based rapid drying system which uses only low capacity magnetons, and we also use vacuum for efficient dehydration. Here we have a patented technology where we have designed the low magnetrons in such a way that there is completely no wave interference is happening at all. And we can start enhancing the capacity of this microwave heating system by simply increasing the height of the machine. So if you look at the area footprint occupied by this system, it is only around 10 to 20 square feet. We can just put it across in any, you have any food processing center, a fish market, a municipal market, an apartment complex, which just occupies a small area. The connected load is only around 5 kilowatt per hour, and we can handle around 50 kgs in a single batch. The reactor, what you see, the unit, what you see here, is around 150 liters capacity vessel. Let's quickly take you through this machine here. We have a central core shaft which contains the heating system, the magnetrons, and we have the control panel which monitors the temperature of the heating system. The metal input is put on the top. We have the vacuum pump which monitors the vacuum. And we have taken here prawns, seafood waste, and converted them into dehydrated products. The value proposition of Mama is like enhanced heating efficiency. For any microwave system you see, there is obviously a heating efficiency completely enhanced in the process. A rapid dehydration because we are able to see very, very fast removal of the moisture in the system. And we get a sterilized output in the process. And we use a vacuum. The major advantage of using vacuum is that we can bring down the temperature of heating so that we're able to retain the nutrition, we're able to retain the texture, we're able to retain the color, we're able to retain the nutrition, and also we're able to end up in a sterilized microbe-free output in the process. And this particular model is scalable, it is modular in process, and it is affordable microwave-based drying systems, and it's a simple plug and play model. We're also doing some research to see if we can incorporate solar panel, solar compatibility to the current systems of 150 liter capacity reactors. So where all we can use microwave heating systems, we have a huge amount of applications in secondary agriculture and in the area of biodegradable waste management. Now, when we talk about secondary agriculture, we are talking about dehydrated products out as output from fruits and vegetables farmers consortium units and fruits and vegetables, seafood units. We have meat processing centers, the ready-to-eat food industries all need dehydrated products in the second agriculture domain. We also look into the opportunities of biodegradable waste management, particularly catering to residential complexes, commercial establishments, markets like vegetable markets, fruit markets, fish markets, and food processing industries, slaughterhouses, and different agro industries, which always produce a large amount of biodegradable waste in the process. So we are able to generate value added products. So, for example, we were able to see, we were able to help silk reeling centers where they have the silkworm waste that comes out in the process. Now, this waste that comes out in the process has a lot of sericin, a bioactive component in the matrix. And we were able to dry that component and also use these dehydrated products as substrates, that organic substrates, for enabling to use enzymes in the process and convert them into highly potent organic pest repellent properties, which can generate enzymes like chitinase and so on. So the opportunity for the dehydrated products in the second agriculture segment, in the biodegradable waste management segment is so huge. And when we talk about taking the waste from apartment complexes or the fish markets or municipal markets, they all contain certain amount of nutrition in them. And we can convert this by dehydration into create a value added product. For example, animal feed, poultry feed, fish feed, and so on. So there are a lot of opportunities for the dehydration, microwave dehydration, generating products in biodegradable waste management segment. So in the case of this is our machine that we have devised and designed, the microwave dehydration segment. So this can actually take in around 50 kgs of raw material. What you see on the right is a dehydrated expeller, and supposing we have around 150 or 100 kgs material which need to be dehydrated at one stretch. We first allow the material to we expel the water from the dehydrator machine, and then this brings down the volume of the matrix, and we're able to put that into the microwave heating system, which rapidly dehydrates to give us the dehydrated product. So we have done extensive amount of trials with fruits, with vegetables, with seafood, with spices, with the food waste, and converted that into value-added products. Here are review pictures with. I'm just giving you some pictures with dried food waste, with dried tapioca, carrots, pepper, prawns, etc. So we were able to do some testing analysis with the food waste that we dehydrated. We took some food waste and put them into the from different apartment complexes, and we put it into the microwave heating system, and we were able to end up with a dehydrated product, the organic food waste. We gave it for testing in terms of to analyze particularly the amount of protein, the amount of crude fat present in it, the amount of fiber, the amount of ash, calcium, phosphorus, and of course, we were able to analyze and understand that this itself can become a raw material for fish feed, for animal feed, and poultry feed. Sorry, I'm not. Yeah, we have actually in Pelican Thermogenics, we have been very fortunate to have got into a huge number of support system in terms of Kerala Startup Mission. We have got seed fund grants. We have got innovation grants from the Kerala Startup Mission, and also from the we are incubated at the Kerala Agriculture University in Kerala under the RKBY Rabi Incubation Center. We also have got the seed funds from the Indian Institute of Management at Calicut. And also we have got support, we have got awards from the National Institute of Technology at Calicut for agri biotechnology and technology for startups. And we're also part of the Tri Kerala program. We're winner in 2021, and we've also been supported by the Indian Institute of Management through the Government of India Ministry of Ports, Shipping and Waterways. And thank you. I hope I was able to give a small input about what is microwave heating and how we can actually apply microwave heating in different types of raw materials. I hope this session was a little useful to you. I'm open to questions right now, and you can reach me. You can reach me on this email ID and this phone number, and to be able to give you more inputs on the microwave heating systems. Thank you, one and all.
Okay. Thank you for the detailed presentation. Now I'll take up some questions.
Sure.
Okay. So the first question is, what are the key advantages of microwave drying system over traditional drying methods in waste management?
Can I stop sharing now?
Yes, you can stop.
Yeah, so I think I actually mentioned that to you. First thing is that it is a rapid system. It is very efficient form of drying system, and there is a lot no drudgery involved in setting up cooling tower, heating, cooling systems, and all these things are not there. Regulatory statutory regulations are all reduced. Then the fourth we have is the connected load is much lesser. Energy consumption also is much lesser. And the last thing is that we are sure of getting a sterilized micro-free output in the process. We retain the nutrition in the process, the color, the texture, the flavor, all this is retained. So if you look at the solar drying, we cannot guarantee whether it is a micro-free output. It takes a lot of time for drying. So there are a lot of technologies for drying. We can use spray drying, we can use vacuum drying, we can use freeze drying techniques. There are so many oven drying techniques, a lot of drying techniques. But the advantage in microwave heating system is the ability to dry inside out, and only the matrix and not the containers. And one of the most efficient form of heating is microwave. I hope I answered your question.
Yeah. Okay. So next question, how can microwave drying systems help in reducing agricultural waste?
Yeah, and agricultural waste, like I told you, for example, we have huge mandis. In Karnataka, we have a lot of mandis in cola, tomatoes, lot of waste generated in a day. What happens is they do not know what to do with it. So we are telling them to actually convert them into dehydrated products and stock it and sell them to places where they are actually being required. So, if agricultural waste, for example, lot of fruits or vegetables or seafood or fishes or whatever, are actually containing some amount of nutrition. So we can there are already people are using the agricultural waste in organic manure applications. We are also talking about using agricultural waste, agricultural produce, the farm produce. For example, the tomatoes. You can actually dry them, dehydrate them, and convert them into, because like tomatoes contain a product called lycopene. So you can dehydrate this waste tomatoes from the agricultural farm produce, and you can keep it as a dehydrated product and sell these to for restaurants as to be converted into purees. It can be used in multiple amount of applications.
Okay. What are the most common agricultural byproducts that can be processed using microwave drying?
What are the most common?
Agricultural byproducts that can be processed using microwave drying.
No, when I'm talking about byproducts, I'm talking about agricultural produce, fruits, vegetables, seafood, um, spices. All these products can be directly dehydrated, and we can get value added dehydrated products.
Okay. Okay. Uh, how does microwave drying affect the nutritional value and quality of secondary agricultural products?
So actually, so yeah, so that the point is that microwave heating systems per se do not affect, because we also include vacuum in the system, so that temperature of heating is drastically reduced. So the system that you see, what we are applying here is we use vacuum up to 760 millimeter on the gauge mercury, so that we are able to bring down the temperature to almost 60 to 65 degrees. So there is no harsh heating happening, which can remove the nutrition or change the texture or anything. So the process itself helps us to retain the color, retain the nutrition, retain the texture, retain the flavor. That is one big advantage with using microwave systems with vacuum.
Okay. Um, what are the energy efficiency benefits of using microwave technology for drying in secondary agriculture?
Yeah, so when we look at normal systems, for example, we have plate drying systems, we have oven drying systems, freeze drying systems. They take more than 5 kilowatt per hour capacities they use, and they the time required for this also goes too much into like more than 8 hours or 10 hours or 12 hours or 24 hours and so on. But in the case of microwave, the system what I showed you currently uses only 5 kilowatt per hour capacity. So even if it goes to around 4 hours, it's only 20 kilowatt per hour capacity. So 20 kWh capacity. So we are talking about energy efficiency in the long-term basis. So definitely we have a lot of energy efficiency when compared to the other systems.
Okay. Can microwave drying be applied to all types of agriculture waste, or there are any limitations?
There are no limitations for using any product can be used. Any organic material, any biodegradable material can be used in this microwave heating systems. Because each of these organic materials contain certain amount of moisture in them, and we only need to dry or remove the moisture. The removal of moisture is what we are doing with the process of microwave dehydration.
Okay. How can microwave drying systems contribute to sustainable agriculture practices?
Yeah, so sustainability is one thing where, so there are a lot of ways in which we can make it sustainable. One is like I told you to develop systems for decentralized processing centers for developing so that you do not have to, you can reduce the carbon footprint in the process. Second is making them more energy efficient. Third is the process by which we can reduce your timing such that you are able to dry more produce in lesser amount of time, and also helping the farmers not to send materials to a centralized facility, and having a decentralized processing centers at their own point of generating these products, so that we are able to help them in retaining. One is creating dehydrated products, that itself is a value addition. For example, fruits and vegetables. If you have dehydrate the cost that is involved in a kilogram of fruits or vegetables and the kilogram of dehydrated fruits and vegetables is so huge a difference. So the value addition there itself is so much. And also with the waste sector, for example, the fish waste, for example, the dehydrated fish from the waste can be used as a high protein substrate in organic agricultural applications also. And also it can be converted into animal feed, fish feed, and poultry feed. So we are talking about applications. Um, all these form a circular, a part of the circular economy, therefore thereby making it more sustainable. So the farmer is not only able to sell his produce, he is also able to generate a secondary income in the process, therefore making his life also sustainable.
Okay. Mm. What are the economic implications of adopting microwave drying systems for small scale farmers?
For small scale farming units, yeah, like I told you, we when we are supplying small scale units, they are generating only small amount of waste. Now, when we're talking about the system that I showed you currently, it handles a minimum of 50 kgs in one for one batch. So when we talk about less than 50 kgs, it becomes a little difficult. So we assume that maybe around 30 kgs for small scale units, 30 kgs of raw material is ideal for microwave heating systems on a commercial level. So for small scale farming units, they don't have to worry about setting up a separate facility for dehydrating their products. They can just put a plug and play system like our system, like microwave system like this, and start dehydrating the produce right in their own facility itself for small scale farmers. So they don't have to, like earlier, if they want, or they a consortium of farmers can come together, and we can set up a centralized facility unit for them in one of the farmers units or so on, so that they all can be benefited by this process of microwave drying.
Okay, right. So, the, I think it will be the last question. Are there any environmental concerns associated with microwave drying set technology in agriculture?
Microwave compliances?
Concerns. I'll
No,
repeat.
there are
Are there
there are
any
no
environment?
concerns, because the machine is totally designed with safety mesh and filters. So while we are making the machine itself, we make sure that there are a lot of safety concerns in the process while designing the equipment itself. We have placed filters on all directions so that the microwave radiation does not come out of the machine. So we obviously have to take the efforts to make sure that the machine is quite safe for use.
Okay. So now the last question. What are the current challenges in integrating microwave drying systems into mainstream agriculture waste management?
Like I told you, the challenges are that in India, the microwave heating systems have not picked up so far. The expertise for microwave is also lacking a little bit here. And the third thing is that there is we need to promote these products on a larger scale. We need to bring out this technology to people through the farmer producers organizations and FPCs, and also through consortiums of farmers, and make them aware of such technologies where they can use this. Now, currently, we also have certain microwave technologies which utilize a large amount of area, footprint, where they put in the through a conveyor belt, and they get dried, and it comes out, the output comes out. But we are talking about a very compact system where we are dealing with uh, 10 to 20 square feet area machine which can dry around like 30 to 50 kgs. Now, for agricultural waste produce, this is one major application that we're talking about, because people do not know what to do with the waste materials, because what we feel and what we need to understand is that the waste generated should not be considered a waste, but it should be considered as a resourceful material. We can convert that into a value-added product. So we need to create a lot of awareness to farmers. We need to make them understand about the secondary applications, about the forward linkages of these value added products in various segments, like I told you earlier, not only in terms of organic manure or organic pest repellents, or value added animal feed or poultry feed, but a lot of other applications for the dehydrated products, especially in agricultural waste management.
Okay. Okay, Dr. Priya. So I think now we have come to end of question round. On behalf of agricultureinformation.com, I'd like to thank you for a detailed presentation and answering all the questions in depth. And I also like to thank my editorial team for sharing their questions. The meeting will now be closed.
Yeah, thank you very much. Yeah,
You're
thanks a lot.
most welcome. Thank you.
Thanks a lot. Can I leave?